All right, welcome back everybody with electricity. Today we're going to be talking about Coulomb's law. All right, so Coulomb law gives us the force between two charges. The force of electricity is equal to this K constant, which is 9 times 10 to the ninth Newton meter squared over Coulomb squared. So K constant times charge 1 times charge 2 divided by radius squared. Okay, one thing that I also want to just say is because we're using, these absolute values, as you can see here, this is going to give us the magnitude, so it's not going to give us the direction, okay? So what is this saying? So it's saying what this force is equal to, if we were to look at this diagram here, it's going to be equal to, 1, how strong this charge is, how strong this charge is, and how far they are from each other. Okay, so depending on those factors, that's going to tell us what the force of electricity is equal to. That is Coulomb's law. Okay, Q1 is the net charge on one object, Q2 is the net charge on the other object, and because we have those absolute values, we're kind of neglecting the negative or positive sign for now. And the radius is the distance between object 1 and 2. Okay, the forces along the line connecting the charges. It is attractive if the charges are opposite and repulsive if the charges are alike. Okay, moving on. So first example here we go. A particle with a charge of positive 8 coulombs is 56 meters from another particle with a charge of negative 12 coulombs. Just letting you know, this is like a lot of charge, but just to understand how to do these kind of problems, I felt like this would be easier. So A, what is the magnitude of the force of the electricity between these two particles? B, is the force attractive or repulsive? So A, let's look at the formula. Force of electricity equals K, Q1, Q2 divided by R squared. So let's just plug this in. The force of electricity is K, 9 times 10 to the ninth, times charge 1, which is 8 coulombs, charge 2, which is negative 12, but we're just going to put 12 coulombs. Remember, we're just using the absolute value, divided by how far they are from each other, and that is 56 meters. So 56 squared. And then let's put that into the calculator. Make sure we put into the calculator correctly. I suggest using a lot of parentheses. So 9 times 10 to the 9 times 8 times 12 divided by parentheses 56 squared. Okay, and then we get this big number that's like 2.76 times 10 to the 8th newtons. Okay, and then the part B says, is the force attractive or repulsive? Well, we know that they are opposite charges, so that means they are going to be attracted to one another. Okay. All right, moving on. Number 2, it's very similar questions. Hopefully try to pause and see if you could do this one on your own. A particle with a charge of negative 3 coulombs is 88 meters from another particle with a charge of negative 4 coulombs. What is the magnitude of the force of electricity between these two particles? Is their force attractive or repulsive? Okay, so when we're doing this, the force of electricity is equal to K times Q1, the absolute value of Q1, Q2, absolute value of Q2, divided by how far they are from each other squared. So let's plug that in. 9 times 10 to the ninth. Charge 1 is just 3, the absolute value. Charge 2 is 4. Divided by how far they are from each other, 88 squared. Again, remember to put a lot of parentheses or else you might mix things up. But yeah, times 4 divided by 88 squared. And then you get around 1.39 times 10 to the 7th newtons. And is the force attractive or repulsive? This is going to be repulsive because they are the same charge. Okay, moving on. Conceptual example. 2 positive charges are one with a charge of positive 4q and the other with a charge of positive q are separated by distance r. Which of the following statements is true? A, the greater the charge exerts a larger force on the smaller charge. B, the greater charge exerts a smaller force on the smaller charge. C, both charges experience the same force in opposite directions. D, both charges experience the same force in the same direction. All right, pause it if you want to think about it. But what we should know is that the force of electricity, you might think it's the larger one exerts a stronger force. However, both charges are going to experience the same force. So remember from the equation, force of electricity is equal to kq1 times q2 r squared. Both of these charges are going to be experiencing the same force. Okay, but what's going to happen is this one is going to be going to the right. Oh, sorry, no, not to the right. They are repulsive. This one is going to be going to the left, while the other one is going to be going to the right. So it's going to be going in opposite directions. Okay. All right, moving on. A distance of r separates two positive charges, both with the same positive q charge. If one of the charges gains a stronger charge, which of the following statement is true? A, both charges will now have a stronger attractive force between each other. B, both charges will now have a weaker attractive force with each other. C, both charges will now have a stronger repulsive force between each other. And D, both charges will now have a weaker repulsive force between each other. Okay, pause it if you like. So one thing we should know is they're both going to be experiencing a repulsive force because they are the same charge. So it says if one of the charges gains a stronger charge, which of the following statement is true? And I think intuitively we know this, but we should know that force of electricity is kq1 q2 over r squared. So if one of the charges gets bigger, that shows that the force of electricity will also be bigger. So that's going to be C. Now have a stronger repulsive force between each other. Okay, moving on. A distance of r separates the positive charge and negative charge. If the distance between the charges increases, which of the following statement is true? Both charges will now have a stronger attractive force between each other. B, both charges will now have a weaker attractive force between each other. C, both charges will now have a stronger repulsive force between each other. D, both charges will now have a weaker repulsive force between each other. So again, like last time, they are opposite charges. So we should know that means that they're going to have an attractive force. Okay, so it's either A or B. And if we look at the equation, force of electricity is equal to K, Q1, Q2 over R squared. And we know that the distance between them is going to increase. That means this R is going to go up. But since that's in the denominator, that means the bigger this is, the smaller this becomes. Okay? So that means that they're going to have a weaker attractive force. The further away they are from each other, they're not going to exert as much of a force, which I think also intuitively makes sense. Okay. All right, so that's it for Coulomb's law. Next time I'm going to talk more about Coulomb's law as well, but we are going to be talking about when multiple charges are here, how do we solve for problems like that? Thanks for watching, everyone. Bye.